Welcome back to Edexcel Computer Science, Paper 1 from 2021, and this time looking at Part 2 of the question paper. I'm going to start with question 4. Algorithms can be used to perform calculations and to process data. State, for 1 mark, what is meant by the term algorithm. Well, it's basically a step-by-step set of instructions that describes how to complete a task. A step-by-step set of instructions that describes how to complete a task. And that will give you 1 mark. And then part B, figure 3 shows an algorithm. So obviously done as a flow chart. We've got start, number 1 equals 1, and we carry on down, and we'll do some counting, and then we've got something at the end, count equals count plus 1, and it loops around until count equals 2. So if I move into a different program, we can see this a little bit better because we've got to complete a trace table, okay, for that particular flowchart. So with this in mind, I'm going to have a little look through what this flowchart's trying to do using the trace table. So we start number 1 equals number 1, okay, which is here. Number 1 equals number 1. Number 2 equals number 1, which is the same, equals 1. Output 1, number 2, next to each other. And there we go. We've got output 1, 1. Count equals 0. Yes, it does. Does count, got a decision box here, does count equal 2? No, it doesn't. Count equals 0. So this is false. Okay? They've put a false in here. Count does not equal 2. So we move on. Number 3 equals number 2 plus number 1. So number 1 is 1, number 2 is 1, so number 3 must equal 2. Output number 3. Okay? Number 3 is 2. Number 1 equals number 2. So number 1 now equals 1. Number 2 equals number 3. Okay, which is number 2. Count equals count plus 1. Okay, and there we go. So background again, count equals 2. No, count equals 1, so that's false. Number 3 equals number 2 plus number 1. So now number 3 equals 2 plus 1. Now this equals 3. Okay, output number 3. Number 1 equals number 2. Number 1 equals number 2, which is 2. Number 2 equals number 3. Count equals count plus 1. Let's go back around. Does count equal 2? Yes, it does. Count equals 2. So that now becomes true. And the program, because count becomes true, we've got a yes and we've got a stop. So the program stops. Okay? So we didn't need to use all the rows, we just needed to fill in 2 additional rows for count reaching 2. So based on that then, the benefits of using a trace table include that they allow variable states, outputs and decisions to be recorded. Give one of the benefit of using a trace table to test an algorithm. Well, it helps to detect problems. It also helps to visualize how this algorithm works, what it's actually doing. So I'm going to put that down. Helps to visualize how the algorithm works. Okay, and that will do. And that will get us a 1 mark there. So 6 marks for that question. Fantastic. We now move on to the next question. An algorithm is needed to count and display the number of vowels in a word. The vowels are A, E, I, O, U. The completed algorithm must count the number of vowels, create a message as a single string. There are number vowels. Okay, print the message to the display. Here is a partially completed algorithm written in pseudocode. Complete the algorithm in the spaces provided. Okay, well I'm going to switch back. Set word to elephant. Okay, is the first message. An algorithm is needed to count and display the number of vowels. So I'm going to set, because we've got count in here, set count to, and we're using the same sort of references as this, set count to 0. For each letter from word do what? Well, I think, based on this, the completed algorithm must count the number of vowels, create a message as a single string. So here we go. I'm going to go, for each letter from word do, if letter equals A, or letter equals E, or, I'm not going to get the formatting right because I'm having to go under each line, but this shouldn't be a problem. Or letter equals O, or letter equals U, then set count to count plus 1. Okay, and then we're going to end the if statement. End for each. Yeah, so this is the for each. Now we're going to end for each. Yeah. So what do we need to do finally? Print the message to the display. Create a single message. So send or output the number of vowels is, and then we're going to add ampersand and count to display. And please forgive me for going into there. So send count to 0. So set word to elephant, set count to 0. For each letter from word do, if letter is A, so we're going round and round and round. If letter is E, if letter is I, if letter is O, if letter is U, set the count to count plus 1. Yeah, and the if statement, and the for each statement, the for loop. Okay, send the number of vowels is the message, because it's in quotes, it's a string, and count to display. So it should display, for the word elephant, it should display 1, 2, 3. So it should say the number of vowels is 3. Okay. Now in question 5, it says computers can be general purpose or specific purpose machines. The central processing unit, CPU, is responsible for executing a program. Figure 4, down here, shows some of the hardware components of a computer system. Complete the table by matching the component to the letters shown in figure 4. Okay, we've got some filled in already. A is the clock, and the clock is connected to B, C, and D. Okay, E is also outside of the CPU. H is outside of the CPU, and G is outside of the CPU. Because it all depends on directional. What are the 4 component parts inside the CPU? B, C, D, and F. Well, C we've got is the registers. Okay. A we've got the clock, and F we've got the cache. Okay. So we need to work out what B and D are. If C are the registers, what is B and what is D inside of the CPU? Well, there's only 2 things that can be inside the CPU, and that's going to be the control unit and the ALU. Okay, and they're both bidirectional, but which one of these is linked to the clock? Well, I can tell you it's B. B is the control unit. Okay, so D, then, by process of elimination, D must be the ALU. Okay, so we've got that one and we've got that one. So now we need to find E, H, and G. Now G has got an arrow pointing from the CPU to the box. So G must be, because it's only going in one direction, G must be an output device. Okay, which leads E, going into the box, must be an input device going into the CPU. So we've got both of those. So the final one, H, bidirectional, and then coming from cache memory into H. H must be the main memory or the RAM. Okay, and that is the order of the letters for the von Neumann diagram for the CPU.
Question 5b, Part 1. The CPU runs a fetch, decode, execute cycle. Some registers within the CPU are general purpose, whilst others perform a specific function. One register is a program counter. Its function is to keep track of the next instruction to be fetched. Describe how it does this. Well, that's a bit weird because it tells you there. It keeps track of the next instruction to be fetched. What it does, it holds the memory address of the current instruction being executed. Okay, but that would only get us 1 mark. It's a 2-mark question. So it then increases or increments to the next memory address. It then increases to the next memory address after each instruction is completed. Not the easiest question, that one. It stores a memory address, would get you 1 mark. Yeah, holds or stores a memory address. Okay, now you'd have thought of the current instruction being executed would get you the 2nd mark, but it won't. You've got to put it increases to the next memory address, or it increments to the next memory address, or it changes to the next memory address after it's been complete. Okay? Part 2, the control bus carries signals from the processor to other components. Identify the signal that would be used during the fetch stage of the cycle. Well, fetching is not deleting, it's not a deletion signal. It's not a storing signal, and it's not a writing signal. Fetching is reading something from somewhere else. It's reading from memory. Yeah, so the answer would be B. Very nice and easy question to get us moving on from that last one. Another 1-mark question. Clock speed is the number of pulses the CPU's clock generates per second. State how increasing the speed of the clock impacts on the fetch, decode, execute cycle. Yeah, so if you're increasing the clock speed, it's going to do, or it's going to process more instructions in the same amount of time. Okay, it basically runs faster. Okay, and that would give you 1 mark. Even runs faster, I think, would get you 1 mark. An embedded system forms part of a larger system, device, or machine. Give 2 features of an embedded system. Okay, so what's an embedded system? It's maybe something you'd find in a washing machine. Okay, to do a specific task. So performs a specific task, a function. But what else does it do? 2 features. Has both software and hardware. But doesn't have an operating system. Okay, unlike a computer. It might have a minimal operating system, but generally speaking, it won't have an operating system. What else does it do? Well, I mean, you could mention low power consumption. It functions in real time. It often uses sensors and actuators to detect external changes in the environment, such as temperature. It generally can't be upgraded. It has integrated memory on board. So yeah, fairly straightforward. Okay, 5C2. There are many factors to consider when choosing a CPU for an embedded system. For example, the clock speed of the CPU in a TV remote control can be low because it only has to be fast enough to create a low-frequency output signal for the TV. Explain one other factor that should be considered when choosing a CPU for an embedded system within a TV remote control. So what we can sort of repeat that a little bit. We can talk about performance, and we can talk about power consumption, based on the last question as well. So performance and power consumption need to be adequate to perform the specific task. But then because it's 2 marks, we need to say why. Because any more would be a waste of money and power. That would get you full marks. That would get you 2 marks. We could also say something like the memory, the RAM, can be very small because it only needs to hold a limited amount of instructions. Okay, the memory RAM can be very small because it only needs to hold a limited amount of instructions. So any of those but, and this is from the mark, and this one's from the mark scheme, but it is talking about the CPU. Okay, and then we move on to question 6. A key code develops software programs. A key code can use a low-level or a high-level programming language to write code. Give one benefit of using a low-level programming language to develop programs. In my opinion, and this is there isn't an advantage because people don't generally write in machine code or binary because it's generally nonsense.
But a low-level language is faster to execute the code because it doesn't need translating, and also no need for an operating system. So either of those, faster to execute the code, no need for an operating system. I suppose the question is he develops software programs rather than he writes. Realistically, he would not write in a low-level language. Anyway, give one drawback of using a low-level programming language to develop, we're back onto develop, to develop a program. So many. Easy to make mistakes, difficult to understand, making it time consuming to write, or any of those. Hard to find errors in the code. Yeah, any of those. So part B, Akiko, again, is writing an antivirus program. The program will include a virus removal function. Give two other functions that should be included. Obviously, a virus scanner to scan a computer's memory drive, a way of quarantining files. Because sometimes you don't delete them, because if you delete something and it's affecting a program that is needed by the operating system, you might want to quarantine it until you can find a solution to removing the virus without removing the actual file. It can also carry out updates. It needs to carry out regular updates. Because new viruses come around all the time, it needs to carry out regular updates for new viruses. So any of those, I would say, would be quite good. For 1 mark, an antivirus program is one type of anti-malware. Okay, give one other type of anti-malware. Why don't they just say, name some malware? Because you've got spyware, you've got adware, you've got ransomware, Trojan horses, and all this sort of thing. But because it says anti-malware, we've got to put the word anti in front of everything, e.g. anti-spyware. Okay? So that would be the answer. Give one other type of anti-malware, anti-spyware. Okay, not Uncle Spyware, anti-spyware. Okay, Edexcel, why? When English isn't your first language, Edexcel, your wording of the questions is sometimes very difficult. Note. Okay, 4 marks. Akiko is also working on a burglar alarm system. Is a busy man. The alarm must only be triggered if the alarm A is set, it is dark outside, a window or a door has been opened. Construct a Boolean expression using and, or, and not with the letters A, O, W, and D to show the condition that will trigger the alarm. Depending on how you look at it, the mark scheme is wrong, but it's right, but the wording of the question is wrong. Because if we look at it this way, A equals 1, yeah, or O equals 1, or, and these are 2 parts, so I'll put this in brackets, W or D equals 1. But this is your problem. The alarm won't go off if it's just dark outside, so these must be joined together with an and. So let's change this to A equals 1 and O equals 1, or W or D equals 1. Okay, so that's a basic expression, but we're going to break this down even more. We're going to get rid of the ones. So it would be A and O, or, brackets, W or D. Word. Okay, so that's how it should be. Okay, A and O, or a window or a door has been opened. That's how I would do it, but I'm trying to read too much into this. Again, the wording of the question is so bad. And then the final question. So Akiko wants to know how the software she writes can be protected. Discuss how the software can be protected from illegal copying and or illegal distribution. You should consider intellectual property and licensing. Akiko's software is protected by patent or copyright laws. Therefore, she can protect her intellectual property. She also doesn't need to apply for copyright protection. She's already covered by that. So that is an easy 3 marks, and that is covered, and that is covering the intellectual property part. We'll then move on to licensing. The software could require a license key or online registration. It could allow proprietary licenses, These allow code to be modified. Akiko could also use Creative Commons CC licenses, allowing free distribution of the copyrighted work. Maybe use this to allow people to share and add additional functionality, to amend, to move forward, to advance the code. Akiko's software is protected by patent or copyright laws, therefore she can protect her intellectual property. She doesn't need to apply for copyright protection. The software could require a license key or online registration. Could allow proprietary licenses. These don't allow code to be modified. Akiko could also use Creative Commons licenses, allowing free distribution of the copyrighted work. Maybe use CC's, Creative Commons, to allow people to share and add additional functionalities of the code, basically making it open source. Okay, and that is it for the final question of this paper. So hopefully 100%, and you've got the full 80 marks. I will see you next time for paper 2. Thank you. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.